Okay, so this one a little different than the other ones. I'll tell you the number one reason it's different. There's more questions. The problem with more questions, you might be horribly confused about what to take first. Um, Certainly, I don't have much space over here, so I'm actually going to go to the answer key and work over the answer key. But if I were looking at this one, and certainly what I mean by this is I would scan it pretty quickly and realize that some of these questions look more difficult than others. But I'm going to, like, from the beginning, I'm going to say one looks pretty easy. I'm going to say two looks like it's manageable. Three, although arithmetically difficult, is still manageable. Let's see. Four, I'm going to say looks somewhat manageable. Five looks somewhat manageable. Six looks manageable. Seven looks a little bit tricky. Eight looks a little tricky to me. Nine, manageable, and 10 looks tricky to me. So I'm gonna just simply say that I think a lot of them look like they're manageable. But here's the problem: they may look manageable, but when I start them, it may be completely unmanageable. All right, so I'm gonna cut to the chase. And I want to say, if I were doing this on a piece of paper and as an exam question, the first thing I would want to do is understand what the question is. Is there's a unique real positive number a, so I know a is positive. I know that much. And then it goes on and says it's a tangent line to this curve. Well, I'm going to draw the picture of that curve. That curve looks like this over here. All right, and there's a point in this curve. It says there's a unique positive real number a such that the tangent line to blah, blah, blah at x equals a. Well, I know the point over here. The point over here is going to be a, f of a, which is a squared plus 1. So I know there's a tangent line there. It's a positive number, but so I'm only put it there. It says it goes through the origin. So this tangent line, wherever it is, goes to the origin. So I'm gonna write the slope down for that line. Now, granted, when I put this line over here, I'm not saying I did a great job, but not bad. So what's the slope of that line? M equals, list the origin, so it's 0, 0. The slope of that line, let's see what you're going to get. The change in y, which is a squared plus 1, minus 0 over the change in x, dy dx, right? So it's going to be a minus 0. Well, that's not that bad. So at least I know the slope of that line is going to be a squared plus 1 over a. All right, now what's the slope of the tangent line at a? I got to write that down. So it's going to be the derivative evaluated at a. And that's fairly easy. The derivative is just 2x, so it'll be 2x. And these have got to match up. So this 2x, I'm sorry, I said 2x, I meant 2a. Let me get my eraser out. Sorry about that. So let's write this down. 2a equals a squared plus 1 over a. And that's a fairly easy equation to solve. What do you get? You would get 2a squared. I'm clearing the fraction, by the way. Now, again, a is a positive number. Keep that in mind. It's not 0, so it's 2a squared equals a squared plus 1. Yeah, this is really low-hanging fruit over here. So it's going to be a squared equals 1, or a would equal plus or minus 1, but I know it can't be minus 1, so a is 1. Clearly 1, okay? This one over here, again, I'm kind of reading it. It says, compute all values of a for which the intersection of these two graphs over here. So I want to point out, if I were to graph these guys over here, the first one, what I'd be graphing at is the line, and the line I'd be graphing at is y equals the absolute value of x. Maybe I shouldn't say it's a line, it's a function, over 2. And that function's not a line, it's a V-shaped object, all right? So I know if I were to graph that out, I get a V-shaped object like this over here. Now, if I were shading that in now, what I'm talking about over here, because it is an inequality, right? If I were shading that in, let me get my shader out, and that would be everything up here now, all right? That's in that V-shaped curve. Now, the other guy's more difficult because there's an A there. All right, now certainly this A could be positive or negative. I'm not sure at this point. But if I were to graph that out, I want to point out, if I were to graph it out, this would be, I'd be graphing out y equals A, absolute value of x, plus 17. Well, you know what? I'm starting to realize that this is a problem that the graph of it should be fairly easy to do. And what I mean by that is I'm just going to look at the, because it's symmetric about the y-axis, I'm just going to be looking at the right side. And what do I know about this over here? I know that, I got a line like this here, and I'm talking about this guy over here, and then I got this guy to graph out, and I'm just going to graph out half the problem now, because I don't have to graph out the other half of it. And the reason I know what the other half looks like, it's just a rotation about the y-axis. And I got a problem over here. I'll tell you the problem I got over here. I know that there's a 17 here, that it goes through that. Now, by the way, it may look like this if the A is positive. It may look like this if the A is negative. It may look like this if the A is 0. All right? Now, what I'm going to try to figure out is the point of intersection. So I'll write that down for you, the point of intersection. And I'm just looking in on the right side to get that. How would I do that? Well, it would be, again, I'm on the right side, so it's going to be x over 2 equals ax plus 17. Now, when I say on the right side, I'm saying x is greater than 0. That's why I removed the absolute value symbol. And what would you get over there? Well, let's take a look at that. You would get x 2ax plus 34. And again, I'm trying to figure out the x coordinate here of what this thing would look like. And yeah, I'm not really sure exactly, but I guess I would probably do this. 1 minus 2a equals 34. You may wonder what I did there. I subtracted 2ax from both sides and pulled the x out. So what's x going to be equal to? 34 over 1 minus 2a. So I know the x-coordinate of the point of intersection, wherever that might have occurred. It might have been up here, might have been down here, but I do know the x-coordinate. And what's the x-coordinate going to be? 34, 1 minus 2a. All right? Now I know the a can't be a half. That would give me a division by 0, right? Certainly don't want that to happen. So let's take a look. Read the question now. Compute all there could be multiple i's, for which the intersection of the graph and the other graph, the region has an area of 51. So what I want to do over here is I want to talk about what the region would look like. And I'll get my shader out. I'm going to say it's above this, but it's below the other one. Right? Whatever that is, it's below these other curves over here. So it's in between. Right? I'm just not sure where it is. Now, certainly, if that's the case, and it says the area, I do want to point out that there's another one over here, but I'm not looking at that now. And I'll tell you the number one reason I'm looking at it. I'm trying to work with symmetry of this. So if all the area, let me get my shader out again. If all the area was 51, I'm just looking at a really simple region of it, which is just this region over here. And that region over there better be 51 over 2. All right, let me put that down. So the area of that thing, which clearly is a triangle. Let's write this down. So the area of this triangle over here is going to be 51 over 2. Well, what's the area of a triangle? 1/2 times the base. Well, this is the base over here. I'm going to call that to be the base, is 17. The other thing I'm doing is I'm doing the height. I'm doing the height. And what's the height going to be? Wherever the height is, it's just going to be the x-coordinate. No matter where the height is, it'll just be the x-coordinate. And come over here, it's still going to be the x-coordinate. And what's the x-coordinate going to be? Well, let's write this down. 51 over 2 equals 1/2 times 17. And the x-coordinate we just figured out is 34. And you get 1 minus 2a. All right? I think I can probably figure out the a now. And I'm gonna do some things over here. 1/2 base times height. Well, let's see, these are nice looking numbers, aren't they? So I'm gonna multiply both sides by 2, that disappears. I'm gonna divide both sides by 17. 17 goes into 51 three times, right? So I get 3 equals 34, 1 minus 2a. Well, let's do this. I'm going to try to solve that equation. That's going to be 3 minus 6a equals 34, and 6a equals, let's see, I can take 34, it's 31, isn't it? Minus 31? Well, a turns out to be a negative number, all right? That stands to reason, by the way. But anyway, what's a going to be? Minus 31 over 6. So it's this guy, all right? It's this guy over here. That's the only possibility. So did I write that down? Yeah. Let's say what they want me to get over here. They say, oh, I only found 1a. What did I find? Minus 31 over 6. Now, I want to encourage you, I certainly read my work if you want. For the most part, it might be tough, but you really need to start working on these problems over here and not so much reading. But you can get stuck sometimes. You have to read. So I'm going to say 1's not that bad, 2's not that bad. I got to be honest with you, 3, I don't like doing arithmetic, but it's arithmetic is what it is. So I'm going to write down looking at it, and as I do it, remember, we're on a clock, and these are 10 questions, but I'm thinking that if the arithmetic is bad, I'm not going to do it, by the way. What would I see? I'd square both sides. I want to point out also it's important you read, and they say, compute the number of ordered pairs of positive integers a, b, c. So I need to come up with this a, b, c business. Now, I would square both sides, and you'd get a to the b plus c factorial equals 28 squared. Now, I certainly would like to do that, right? Now, if it's going to take you a long time to do 28 squared, I wouldn't do 28 squared. I would just go to another problem. But I got to be honest with you, what's really kind of disturbing me most is that c factorial. So I want to point out it's a to the b is going to be 28 squared minus c factorial. All right? Now, I grant this is why you're doing that. The c factorial is probably the most aggravating thing I have to deal with. All right? So I'm going to say I'm looking for the biggest c could be. And I'm going to write this down for you. 6 factorial. What's 6 factorial? Let's see. That's going to be 784. All right. Now I'm not going to bore you with all the details of me computing, but what I'm going to do is I'm going to work. That's the most it could be, by the way. And I'll tell you why. I'm kind of looking at the 28 squared. Maybe I should write that down for you. 28 squared. 8 times 8 is 64. 8 times 2 is 16 plus 6 is 22. And then 2 times 28 is 56. This is 4. 6 and 2 is 8, 784. Wait a second. 6 factorial is not 784. I'm sorry about that. 6 factorial. I did 28 squared. I said 6 factorial. I'm so sorry about that. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. This is 30. This is 12. And this is 2. Let's see what you get over there. 24. 30 times 24. So that's going to be 640. Let's say I'm doing that right. I'm sorry, 720. I'm really getting screwed up here. I don't enjoy doing arithmetic, but it's number one reason. So I'm going to say 7 factorial would be way too big, all right? So I have to work my way backwards from 6, all right? And that's tough. I'll be honest with you, it's tough for me. So let's write this down. And a to the b, I'm going to put down c is 6 here. And a to the b, I'm doing 28 squared minus the c factorial for each of these problems, by the way. And, I did the arithmetic beforehand. I'm just going to write down what I'm getting over here when I do this. And this is the arithmetic that you would have to perform, 64. When you do C5, and again, I did the arithmetic before. You would have to do that arithmetic yourself, by the way. That would be 664. And I'm going to keep moving through it. And I'm working backwards. And C4 would be a to the b equals 760. By the way, the numbers I know are getting bigger. They're getting more complicated. A to the b. And again, what I measure we're doing, 28 squared minus c factorial. All right, now if I do 3, you would get 778. And again, I'm working my way backwards. They tell me that a, b, and c are positive integers. All right, let's go 2. And 6, 5, 4, 3, 2. I'll eventually get back down to 0, by the way. What do you get over there? If c is 2, you get 782. And then I got c is 1. A to the b is going to be 783. I would do c 0. That's 0 factorial, which is 1. Just like in the same problem, by the way. A to b equals 783. I got troubles, though. Whoops, sorry about that. I'll tell you what my troubles are is a to the b, and they tell me they're integers, and there's possibilities over here, and I got to write them down for you. So it could be 2 to the 6. This is an easy one, by the way. It could be 4 cubed, or it could be 8 squared. They'll all give you 64. Now, 664, if you were to factor that, you would get 2 cubed times 83. All right, we'll talk about that later. The next one's going to be 2 cubed times 5 times 19. The next one's going to be 3 times 389. And yeah, I had to do the arithmetic, by the way. I kid you not. And I just don't enjoy doing arithmetic. And some people are really good at it, but I tend to get befuddled sometimes and say, oh, I'm tired. I can't go on anymore. 3 cubed times 29, and this would be 3 cubed times 29. Now someone says, I don't even know what to do with all that information. Well, you're going to write down ordered pairs. So I want to point out the first one is going to have a 6 on the end, so it's A, B, C. And then what do I get? I could do 2, 6. Let me tell you where this is coming from right here. I could also do this one over here. I could do 4, 3. That's still a 6. I'm doing this first line over here. What's the next one going to be? It's still going to be 6. And I just did this one. It's going to be 8, 2. All right? So 2, 6, 6, 4, 3, 6, 8, 2, 6. Let's go to the next one. The next one's going to be a 5 now. So we just killed this guy off. Now this one's not so bad, and I'll tell you why. Looking at this thing, I just can't get the A to the B unless the B is 1. The only way I could do it. All right? So what's the power going to be? It's going to be 664 to 1. The next one, same story. What do you get over there? 4. And you only could do that as a 1. The power is going to be 1, 760. All right, so I did this one. I did this one. Let's go to 3 now. That's going to be 1. What's the power going to be? 1. What's the base going to be? 778. Let's do the next one. 782, 1. Again, I'm looking at these things over here to do that. That would be 2. What's the next one going to be? Let's see, 783, 1, and 1. And then I'm going to get, let's see, 783, 1, and 0. Let's count these things up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if I got everybody down. Let's see. I got 3, 4, 5, 6, 7, 8, 9. Did I miss anybody? 6, 5, 4, 3, 2, 1, none. Let me make sure I got everybody down. I think I missed somebody. Let me just see if I counted everybody up. 266, 436, 826. I'm just going over these again. Oh, I missed one. And I'll tell you what I missed. I missed this guy, the first guy. I knew it. It's right over here. And what's that going to be? 64, 1, and 6. Sorry about that. So there's going to be 10 pairs. All right? Now, granted, you might say, what if I miss one and I get it wrong? I mean, some of the competitive exams, yeah, they're looking for the best person's work. My work looks horrific at this point. We'll look at the key, by the way. But I think I did go through this. So C has to be less than 7. 6 factorial 720. I start with C is 6, and I work my way backwards. And I think I got them all listed over here. And how many would there be? Let's count it up, make sure there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we said, 10. All right? So I want to point out in a competitive exam, a lot of times what they're looking at is, neatness counts. It really does. You notice I type up my work, by the way. I wish competitive exams would allow people to retype their work, by the way, after they submit it. So it looks a lot neater. I just want to give you a short story. I believe the Chinese, they're, for their, by the way, I'm talking about ancient Chinese, I should say, when they submitted exam papers for very important positions, by the way, and these are very important positions, a lot of people would compete for that, and what they do, they'd have one scribe rewrite all the papers. And the number one reason for that was penmanship, that they wanted to make sure that they were not being discriminated on based on how poor their penmanship was. So a scribe took everyone's work, rewrote it in the same penmanship, and that's where it would be graded, all right? So, I mean, you certainly need legible penmanship for a scribe to translate it, but it's doable. But that wasn't so bad. All right, let's look at number 4. I'm still thinking maybe it's low-hanging fruit. It says for some constant k, the polynomial p of x has the property that p1 is equal to p10. Well, let's write that down. What are you going to get? Well, p1 would be 3 plus k plus 117. And this is p1. What's p1? It's k plus 120. And what do I know? I know p10 now. What's p10? Again, I'm looking at the polynomial. It's going to be 300. Again, I'm looking at the polynomial. Plus 10k plus 117. And what did they say? And again, they said that p1 is identical to p10. Well, k plus 120 is equal to, well, that's going to be 417, right? This is p10 over here, by the way, plus 10k. Well, let's see if we can do that. It looks pretty difficult, but I think I can handle it. And let's take a look at that. You get 9k, right? And then what do you get? I got to write that down. So 417 minus 120, that's 7. This is 3. That's 11, 8, 9, and 297. So minus 297. All right. Oh, I got to do some more work, don't I? Get my eraser out. And remember, I really don't enjoy doing arithmetic, but I think I can do that. And I certainly do this by 3, but I'm gonna give it a shot. Maybe 9 goes into that. Let's put this down 9 into 297. That would be 3. That's 27, 27, 33. So what's k going to equal to? Minus 33. Now, by the way, I'm not saying they asked for that. I'm just saying that was really low-hanging fruit. I got the k. What did they ask for? Not k. They asked what p20 was. Well, what do? 3 times 20 squared. K is minus 33 times 20 plus 117. Now, I got to be honest with you. Again, my theme today is I just don't feel like doing the arithmetic, but I'll do it for you, and I'm going to factor it. And so this is why I still don't feel like doing the arithmetic. It's 3 times 20. And what did I get over there? I would get 20 minus 11. Let's see if I did that right. Yeah, plus 117. And this is going to be 60. And 20 minus 11 is 9, plus 117. And let's see, that's going to be 540, right? Plus 117. And what do you get over there? You get 657. So we got it. All right? We did it right. Let's go to number 5. Number 5, looking at it, I got to say that the geometric comes up a lot, and this is clearly a geometric. I want to point out what I mean by that. The geometric, and that's R, not R, I'm sorry about that. I got R in my mind. I'm going to say J equals 0 to infinity. R to the J is going to be 1 plus R squared plus yada, 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 goes up to infinity. And this sum exists. It's 1 over 1 minus R. I'm going to make this R a little different. Provided that the absolute value of R is this over here. All right, so I'm going to say this looks like that. And what I mean by that, if I did this thing, I'd get 1 plus this crazy looking thing over here plus this crazy thing over here. You get the idea, right? 1, 2, goes on forever. I know the sum of this thing. By the way, it's conditional, but I know the sum of it is going to be 1 over 1 minus the common ratio, which in this case over here is just x over x plus 1. I'm going to try to simplify that by multiplying top and bottom by the minor LCD. It would be x plus 1. On bottom, if I multiply by x plus 1, you get x plus 1 minus x. And so I would just get x plus 1. All right? That's all I'd get there. The bottom is just a number 1. Yeah, provided that the x is not equal to certain numbers, but we'll talk about that in a moment. So what do I know about this over here? That conditionally, when I mean the conditions, I get the conditions in x over here, this would sum up to x plus 1. And that might seem like a miracle to you, but that's what it sums up to under given constraints. And the constraints are going to be as follows, that the common ratio, and I'll write this one over here for you, the common ratio, the absolute value of it has to be this over here. All right, now I have answered, inequalities are always tricky. And so what I don't do is I want to talk about what this means to me. That whatever this thing is here, it's got to be between these two numbers now. All right, I move the absolute value symbol. Now I know what some students want to do. They want to multiply everything by x plus 1. That's a bad story. You don't want to do that. You never want to do that. All right, unless you want to put the conditions down. I don't want to go there. But I need to solve that inequality. And the first one I'm going to do is minus 1. And I'll do this one over here. This is connected by an and. And the and, this x over x plus 1 has to be less than 1. Well, the way your pre-calculus teachers taught you this, they said compare it to 0. I'll put this down. This is going to be x plus 1. And that would be what? That would be x plus 1, which is 2x plus 1. And I can do that inequality, by the way. And by the way, this is an and. I didn't do the other one yet. But I'm going to say minus 1. That's where the bottom becomes 0. That's bad news, but it does change signs there. And the top becomes 0 at minus 1/2. And then they told you to do sign analysis. If you took a number after minus half, like 50, and plugged it in, it'd be positive, which is what I want. Minus 1/2 is not is going to give you 0, so that's not greater than 0. If you want between minus 1 and minus half, like minus 0.7, plugged it in, it would turn out to be a negative number. I don't want that. And if you want below minus 1, like you did, like minus 50, it would be negative 5 by negative positive. So this works out over there. That's good news. I'm going to do this one. And what do you get over there? Well, let's write this down. It would be x plus 1 less than 0. Subtract 1 from both sides. So it'll be minus 1 on top now. Pretty basic stuff. I can multiply both sides by minus 1, and you get this over here. So I'm going to put the number line down next to this. I want to point out what and means. It means the intersection. And it's going to be at minus 1 now. All right? Now, to the right of minus 1, we're solving this inequality over here. It would be definitely positive. So where do they intersect? They intersect from minus 1/2 to infinity. All right? So I'm going to tell you this over here, that this sum here is only going to be true if I'm starting at minus 1/2 and I'm going off to infinity. It's the only way it could be true. So x has got to be on that interval over here. So this is what the function looks like. What do they want me to do with it, though? They want me to graph it and clearly indicate its maximal domain and range. Well, you know what? I got to graph that guy now. And I am kind of running out of room, but I think I can graph that guy. And what does it look like? Well, it starts at minus 1/2, right? And what would you get over there? It would start at minus 1/2, 1/2, and then it goes off with a slope of 1 like that. So the domain is going to be minus 1/2 to infinity. That's the x values. Its range is going to be from 1/2. Again, the range is the y values, 1/2 to infinity. All right, let's take a look, see what we've done. And we got the domain down, we've got the range down, and they got a picture down. Their picture's going to be definitely better than the one I put on the paper over here. Let's take a look at it, and I'm seeing it. And it's really very similar to my picture, and their picture's better, by the way. Again, this goes on forever. Let's take a look. And I think I did 5. We're on a run. I'm going to talk about this problem now. It says Abby starts at 1 and counts forward. And I see the sequence. And Abby's counting up by 3s. So 1, 4, 7. So I'm going to put down Abby's sequence as AN. And this is an arithmetic sequence. So A1 is 1 plus N minus 1. And then what I get for the common difference is 3, right? And let's see if that works out. So if n is 1, I would get 1. If n is 2, I would get 4. Yeah, it seems to work out pretty good. All right? Let me write down an for you. And what would that give you? N minus 3 plus 1 is, 3n. And we'll check it too. 3n minus 3 plus 1 is 3n minus 2. Let me check that again. If n is 1, I would get 3 minus 2, which is 1. If n is 2, I'd get 6 minus 2, which is 4. If n is 3, I'd get 9 minus 2, which is 7. If n is 4, 12 minus 2 is 10. Yes, working out beautifully. Let me put down the other guy, and the other guy's Bobby. I'll call it Bn. And that's also arithmetic, but he's actually going backwards, all right? So what's A1? It's 2017. And then it's going to be plus, let's see, and again, just doing the arithmetic, and arithmetic is something you studied probably in algebra pre-calculus. What's common difference there? It's going down by 5. 17, 12, 7, say down by 5. So what do I get over here? Bn, it's more difficult, the numbers are bigger. I get 2017 minus 5n plus 5. So what do you get over there? Well, 2022 minus 5n. So I got Abby's sequence and I've got Bobby's sequence over here. Now, certainly someone's counting forward, someone's counting backwards, and they say at the same time and at the same rate. All right, this is important. So they're going forward and backwards, starting where they said they're going to start. Abby's going forward, Bobby's going backwards. They say find the one number that both Abby and Bobby count at the same time. Well, what does that mean? It means that their sequence, there's going to be some number in the sequence where they're going to be equal. So I'll write this down for you. So 3n minus 2, there's going to be some n that it occurs at least I hope so. And n's got to be an integer, by the way. It may be none of the above, by the way. But let's take a look at this and see if I can solve that equation. And that's going to be 2024, right? I'm adding 2 to both sides. And then I add 5n to both sides, 8n. I'm going to take, let's divide by 2. You can get 4n equals 1012. I'm going to divide by 2 again. You get 2n equals 506. And I'll divide by 2 again, and we get, let's see, 258. All right? Now, I'm sorry. I said 258. That's crazy. I don't know why I even said that. It makes no sense at all. 2 goes into 506 253 times, and sorry about that. That happens on competitive exams. People put down, the wackiest things. I guess they're daydreaming or something when they write it down. But 253. All right. So I'm going to say, what was their question? Their question, it says, I have to read it again. It says, find the one number. Oh, geez, I didn't do that. I just found the n. So let's put down A253. What's that going to be? Well, 3 times 253 minus 2. That would be 600. 150 plus 9 minus 2. Let's see, 759, 757. You know what? I want to look at Bobby's too. What's 253 for Bobby? Well, that's going to be 2,022 minus 5 times that number. Well, let's write this on the side. 5 times 253, 15, 25, 26. 5 times 2 is 10, 1265. Yeah, I got to do some arithmetic here, don't I? 2022 minus 1265. Let's see, I'll borrow. This will be a 1. This is 12. That's 7. Oh boy, this is going to be 1. This will be 10. Borrow 9. This is 11. 6 from 11. 4, 5. And then, borrow from the 10, so it's 9. 2 from 9 is 7, and 1 from 1 is 0. 757. Yep, they'll count to that. Both of them will. All right, so we got that one right. This one over here, again, I'm reading it. I'm thinking maybe I can do it. Maybe it might get stuck on it. I don't know. It says over f of x equals log base b of x. They tell me what g of x is. Then they tell me this over here, that f of g, well, let me write that down for you. F of g of x is 0. And that's set over here, by the way. I got to do that. So f of g, what's g? X squared minus 4x plus 4 equals 0. What does f do? It takes log base b of this number over here. Well, I always tell my students when you're doing logs to write them as exponentials. And what are you going to get? You're going to get x squared minus 4x plus 4 would equal b to the 0. I want to point out that b is a positive number. All right? I know that much for that to be a log. And so b to the 0 is going to be 1. So what do we get here? X squared minus 4x plus 4 is equal to 1. I think I can handle it. And what do you get up there? X squared minus 4x plus 3 equals 0. And I'm going to try to factor this guy now. And I'm hoping it works out nicely. 3 and 1 minus minus. So x could be minus 1 or, plus 1, or x could be 3. All right, so I got two numbers there. So but it doesn't know what b is, but I know x could be 1 or x could be 3 at this point. So I'm going to keep going. And the next thing I'm going to write down is the other one, which is g of f of x. And that equals 0. Well, let's write this down. And what's f of x? Well, I'm looking at it. It's that log problem, isn't it? And let's take a look. That equals 0. What does g do to it? It squares it. I'll write this down for you. So it's going to be log base b x. That's going to be squared. Let's see, minus 4 times that log bx, and then plus 4 equals 0. Well, that looks much more difficult, by the way, but it looks like it might be factorable. Let's write this down. Log base b of x, log base b of x, and we got a 4 in the end, right? Let me just see if I got that right. Looks like minus 2, right? I'll put this over here. And I think I can handle it. And what I mean by that is these have to be 0. So log base b of x is equal to 2. So x would equal b squared. Right? Well, let's take a look at this. And I gotta be careful here. Well, I do have to be careful here And I'll tell you why I have to be careful. I don't think x could be 1. And I'll tell you the number one reason over here. If that were the case, right, if x were 1, the log base b of 1 would be 0. And this would be, no way would it ever equal 0. So I'm going to just throw that guy out. Let's try the 3. So to give you 3 equals b squared. Well, this looks pretty easy to do. What's b going to be? And I want to remind you that b is a positive number. B is just the root of 3. Done. All right? Let's keep going. 8, I'll be honest with you, it looks really tough to me. All right? I'm not saying it's impossible. I'm just saying it looks really tough. If I were doing a competitive exam and I got the problem number 8, I would be looking for more low-hanging fruit. All right? So I want to go to number 9. And I believe number 9 is low-hanging fruit. And why is that? It says, let Q be a real number. Suppose there are 3 distinct positive integers, A, B, and C. I know they're integers, such that this sequence of events is geometric. I want to point geometric, and by the way, I noticed in my key I put an inappropriate choice of using the letter A over here. So I'm going to put over here, a geometric sequence looks like A times some common ratio, and then A times that common ratio, so it'd be A squared, all right? Now, once I understand what geometric means, I start to realize if this is geometric over here, it's got to have the same properties over here, all right? So what I'm going to say over here is that, the middle term, right, this middle term over here is just a product of the outer terms, all right? So I'm going to write that down. So I'm going to look at the outer terms for this sequence over here, and the outer terms, right, let me write this down. The product of the outer terms is the square of the middle. So let me write this down. So the big A times this is the outer terms. This is A, that's AR squared, is the same thing as the middle term squared. All right? So what I'm going to do is I'm going to get my eraser out, and I know that much about geometrics, and you might have remembered that from your pre-calculus or your algebra class. So let's put this down. So what do I know? I know Q plus A, these are the outers, times Q plus C is equal to the square of the middle term. So it's going to be Q plus B squared. All right, this is an important event now. So, by the way, you may not know what the question is at this point. That's fine. I'm just writing down things I know about. So what do you have here? You get Q squared plus, I'm going to put down, I don't know, I'm going to write down A plus C cubed. And then you're going to get AC. And what do you get on the other side? That's going to be a little tougher, isn't it? That's going to be Q squared plus 2QB plus B squared. All right? Now I'm going to subtract Q squared from both sides. That's gone. I'm really trying to find Q, aren't I? So let's put this down. A plus C Q, I got this, minus 2QB, right? I just did these two terms now, is going to be, let's write this down, B squared minus AC. Again, I hope I didn't go so fast you couldn't follow that. All right? What's nice about video, you can always pause these tapes, by the way. Let's just factor the Q out now. And if I factor the Q out, what do you get? You would get A plus C minus 2Q equals B squared minus AC. All right? Let's go back to the question, because right now you might say this is just going nowhere. And I want to point out the original question was this. Let Q be a real number. Suppose that there's 3 distinct positive integers a, b, and c. That means they're integers, they're positive, but they're not the same integers. They're distinct integers. And they say it's geometric, with understand the q. They say q is rational. So I'm almost there, by the way. But I do have a trouble over here. Now, to show it's rational, I got to show it's a ratio of integers. So I'm going to write this down. Q is equal to b squared minus ac over a plus c minus 2. I'm sorry. I wrote down 2q. It's not 2q. I got to erase that. That's a b. My apologies. 2b. Okay? So, by the way, this is rational provided a plus c minus 2b does not equal to 0. And I got to be honest with you, let me just, kind of look at this key, but I realize I'm not done yet. But I noticed I have this written over here, and I have this written down. Are they the same thing? They are. You would just simply multiply my expression by minus 1 over minus 1, and you would get a squared minus b squared. And on bottom, you get 2b minus a minus c. I got to be honest with you, I'd be very happy to see students get that answer. But again, remember this, when you're in a competitive exam, you're going to be shocked at other people's work, how detailed they are, how neat they are. I got to show that this thing is not 0, by the way. All right? I realize this is going on a long time, but I got to show this. I have to. So I write it down, and then I start working on it. Right? So I want to point out what I probably would do over here is just, I just work on this thing. My hope is to show it that it's not 0. And the way I would do that is probably, maybe write down 2b equals a plus c, right? And then what I did was I squared both sides. You got this over here. That looks pretty easy to square it, by the way. All right? Now someone says, what are you doing over here? I'm doing something that you may not realize why I'm doing it. And let me go through that with you. So I'm going to claim if this is 0 here, this would have to be 0. So what am I claiming? I'm claiming now that AC is equal to b squared. All right? And that's written right over here. All right? So what do? I kind of look at it. I guess I've subtracted 4ac from both sides. I get this line over here. I realize it's a perfect square. You get the idea? I realize it's a perfect square. Here's the deal, though. This is a contradiction. And why is it a contradiction? I'm saying it's equal to 0. The only way this could be equal to 0 is if A equals to C. And here's the get-go. Right from the beginning, they told you they're distinct integers. In other words, A and C are not the same integer. So this is a contradiction. Sorry about that. It's a contradiction. So it's a contradiction. So I'm going to say over here, that's not going to be 0. So 2b minus a minus c is not 0. All right? A lot of detailed work over there. All right, so I think there's 2 problems left. All right? And what I'm going to do is I'm going to say that for a lot of students, what happens when there's 2 problems left is they're glad there's only 2 problems left. Right? Even if this was a traditional exam, you got, you're looking at, you did 8 problems, and that's not bad. So I'm going to just simply, let's talk about this. Let's see where we are. What problem I didn't do? I think I did 6. I think I did 7. Oh, 8. I didn't do 8. Right. I know we're getting close to the end of it. I just want to walk you through it. And I know it's difficult. I always find students find it very difficult to follow when things are written down. And then they say, could you talk me through it? And I say, yeah, sure, I'll talk you through it. So I'm going to say over here is I wrote down their problem here. And then what I do is I made a substitution. Now someone says, I have a better way of doing it. We're not saying you don't have a better way of doing it. But if I made this substitution over here, I want to point out, really what I'd be writing down is I'd write down x equals minus u, and then I'd write down dx equals minus du. and I make a substitution. And if I did that, I would get, let's see what you get. Let's make sure you get everything we say we get. So I would definitely get this as an upper limit. This is a lower limit. I'd get this, and du would be dx would be minus du. That's why I'm getting this over here. All right? So someone says, well, and again, you might say this is by pure chance you did this. No, I do things because I don't know what else to do. And I'm doing something that looks simple to me. So what I did was I took that integral and I multiplied the top and the bottom by 2u. Someone says, why would you have done that? I don't know. I guess to get rid of the negative power. And what do you get there? Well, very little changes. All right, very little changes. Oh, by the way, I want to point out another thing I did. I changed the, because there's a minus sign in front, so I just flipped the limits. You notice that? Let me make my eraser. I just flipped the limits. I didn't notice that before, but I just flipped it. I just noticed I did that. So what do you get over there? Multiply it out. Yeah, not that bad. All right. Now, when I get to this line over here, let me start to erase this business over here too. So we talked about that, and now we're here. And someone says, what are you going to do now? And again, I'll be honest with you, I sometimes I get stuck. I say, I don't know what the hell I'm going to do with that. But I'm going to try to make it look sort of like the other side. Right? It sort of looks like that now. So I'm looking at it, I'm seeing this, right? But now I got a u over here. So all I did was I made another substitution over here. I didn't write it down for you, but I said, oh, just let u equal x. So du would equal dx. And if you did that, you'd get this over here. I'm going to be erasing this in a second, by the way. So I said u is equal to x and du is equal to dx. So I got this over here. Let me erase this business. All right, we're going line by line. And these lines are getting bigger and bigger over time. So I'm at this line now. All right. Then what did I do? I just simply said they're equal. I said whatever this is, it's identical to this. And that looks really strange to me. But they're equal. That sounds remarkable to me. We step by step and got there though, right? Then what did I do? It looks like what I did was I added the same thing to both sides. What did I add to both sides? This thing over here. So I added to the left side, and I added to the right side. All right? Now when I do that, I got these two integrals, and I combine them together. And I'd get this. Now, so when I'm studying these things, I'm studying my own work, by the way, but I'm kind of seeing that. I mean, they got the same limits integration. I'm just adding their integrands together. And then I factored in 1 plus x squared from the top, and you would get 1 plus, yeah, I got that. And it equals this thing over here. Let me get my eraser out. I'm going line by line. I'm going line by line. And where's it going to end? Oh, look at this. This is a miracle. I'm seeing this cancellation over here. And I get something really simple. All right? Really simple. I get an integration I can do. I finally found something that I can actually do. And this integration is very simple to do, and I hope you have no trouble showing that's 28 thirds. What I mean by that, this integration produces x plus x cubed over 3, and I evaluate it from minus 2 to 2. That's very simple to do. It's going to be 2 plus 8 thirds minus 2 minus 8 thirds. And what's that going to give you? 2 plus 8 thirds plus 2 plus 8 thirds. That's going to be thirds. When you get 6 plus 8 plus 6 plus 8, let's see, 16 and 12, 28 thirds. All right, that's not so bad. All right, again, I'm just following my work. That's all I'm doing. And that's what you're doing when you're studying too. All right, let me just get rid of this stuff over here. So I'm at this line now. Someone says, what the hell did you want to do? I want to get the original integration. And what do I notice now? I got this over here. And let me put a check mark here. I'm at this line over here. Divide both sides by 2. And what do you get? You get this over here. you're still in trouble. But I want to point out, I see this trouble before. And what do I know about this guy over here? It's identical to this guy over here. So what do I do instead? Instead of writing that one down, I write this one over here, and I got the integration done. It's 14/3. Yeah, it's tricky. There's no doubt about it. It's tricky. That we did 9. I don't think I did 10 yet, and I'm going to walk you through it, all right, one step at a time. So as I do this over here, I want to point out they tell me that f satisfies this over here, and I'll use it. And how did I do that? Well, I wrote down, I guess I saw for f of x. That should be, you should be able to follow that just from that line over there. By the way, I do have to do the integration, but I'll be honest with you, that integration doesn't look easy. All right? So I got the first line down. I'll put a check next to it. And then someone says, what'd you do there? I don't know. I guess it looked like I differentiated. Let me write this down for you. F of x equals x times e to the minus f of x. Let's write this down. F prime of x, this implicit differentiation, by the way, would be 1 times e to the minus f of x plus x times e to the minus f of x times, I'm using the chain rule, minus f prime of x. Let's see if we see that. I'm seeing the first term, and I am seeing, yeah, I'm seeing this one too. I'm seeing x. I'm seeing f prime of x. I'm seeing the minus sign. Yep, I'm seeing it. So someone says, what are you going to do now? I guess what I did was I just added those together. All right, pretty easy to do, by the way. So let me just erase my chicken scratch over here. I'm just going line by line to make things look good. This is what a grader would do too. And they'd say, gee, they're moving forward. They may be moving forward, but at the same time moving forward may not be able to get the actual result of the problem. But, you know, this one, pretty easy. This one was pretty easy. I'm at this line over here. I want to go through that with you, though. And someone says, how'd you get that? I mean, how did you do that? I'm going to write that down for you now. How did I get there? Let's write this down. So let's write this down. So f prime of x is equal to 1 minus x f prime of x e to the f of x. Well, I'm going to write this down. This is going to be f prime x times e to the f of x. Again, we're trying to get this over here. Let's see if I can do it. And then you're going to get 1 minus x f prime of x. Well, I'm going to get the f primes on one side now. I'm going to factor it out. And what do you get? E to the f of x plus x equals 1. So now I'm starting to see it. What's f prime going to be equal to? It's 1 over e to the f of x plus x. And I see it right over here. I did all right. Let's keep going. Get my eraser out now. Remember, these are recordings. You'd always pause the recording if you want and copy things down. But I'm just working through like an answer key. And this is a really good way to study a textbook, by the way, that you're going to see work down. You wonder, how did they do that? You got to get paper and pencil out to see how they did that, all right? There's no way you look at that and know what they did. So you did the work yourself, all right? So then the question becomes is they made a substitution. And again, this might seem crazy, but it's something we do a lot in mathematics, all right? So, you know, I'll write this down for you. So if I said u is equal to f of x, I would say, you know, du would be f prime of x dx. You could do that, right? So, yeah, I guess I have that written down here, don't I? All right? I got that written down there. So what's that going to be equal to? Well, let's take a look. Do I know what f prime is? I sure do. It's right here. And that's why that's written down. All right, so what do I see? I see that what I had written up there. So that's what the f prime is, and I'm putting that over there, and that's the dx. And again, this is still the du over here. All right? Then what do? I'm still using that same substitution, which is u to the f of x. I'm sorry, u is equal to f of x. So I put this thing over here, and I see this over here now. All I did was I replaced f of x with u. All right? So what do? You get something pretty convenient. I multiply both sides by, and again, this is still du. So I get dx on one side, I get du on the other. All right? Now I realize people are saying, I still don't know where you want to go with the problem. All right? So what I want to do is just say, let's go to the next page, and you say, what did the guy want to do? He really wanted to do this. So you might say you spent an awful lot of time doing this stuff over here to get an expression that you have no use for. Well, maybe that's true. I don't think so, though. All right, let's go over here. So let's take a look over here. So what's f of x? Well, it's over here, right? Remember? We did this many times. F of x is x over e to the f of x. Whoops, sorry about that. So I wrote that down. That's all I did, wrote it down. Then what do? Well, I do that substitution. So what substitution am I talking about? The one we just talked about. So what do we got? Let's go back over here. I know this business here. So what's dx going to be written down as e to the u e to the u, du. And what's x equal to? Gee, I can't remember. So let's take a look at that. And what was x equal to? Let me put this down. I think we said, what did I say? Let's put that down. And where is that? I get the dx, x over e to the f of x. Oh, now I see. So remember what I said, u was equal to f of x. So what do you get in bottom? You get this over here. And this is e to the u here. I'm sorry, the substitution. So let's talk about the x. And I'm kind of looking at it. And I think I'm going to use this here. And what would you get? I said f of x is equal to u. And this would be x. And then I'd get e to the u. So what's x going to be equal to? E to the u times u. Let's go back over here. And we got this over here. So someone says, I still don't know where this is going. Well, look, it's not looking bad. I'm telling you, it looks really simple at this point. I know it's tough, by the way. If this was a competitive exam, people would be bogging down saying, does this thing ever end? Well, I want to point out what I'm doing over here. I'll write down for you. I'm seeing this cancel off. And what do you get? Multiplication. So you get u e to the u squared e to the u du. And then what I do integration by parts. All right, I know that's tough, by the way, but I did by parts on the problem. So I'm going to leave it to as an exercise for you guys to work over this part over here and get the results over here. So I got the antiderivative over here, and then what I do, I basically put the limits of integration in now. So we just did this. I got the antiderivative, and I basically plug in, what do I plug in for this over here? I plug in f of x minus x plus e to the f of x. I don't put the c down, but the limit should be 0 to e. And I kind of pop it in there, and you get this over here. All right? Now, again, people are still looking at that saying, where is this going? Well, you got to start thinking about it. All right? And the part of thinking about it is it does take a lot of effort to do that. So we got this over here. I got this evaluation done. Let me get my eraser out. It's tough, though. I know that. A lot of work. And by the way, this would not be the first problem I choose on the exam. It's just way too much work. I'd look for low-hanging fruit. I always say that. Look for low-hanging fruit. Let's keep going. And it says, oh geez, x equals 0, f of x. You'll see that f of 0 is 0. Yep, and here's the reason why. If that's the case, let me point out what I'm talking about over here. If x is equal to 0, e to the f of x is a non-zero number. So that implies that f of 0 must be 0. All right? And also they say let x equal e. That's something you have to figure out. What would you get over there? You would get, I'll write that down for you. You would get e equals f of e times e to the f of e. All right? Now, it's more difficult. There's no doubt about it. But, kind of looking at that, I know that the left-hand side is e. So how would I get that to work out? That would only work if f of e was equal to 1. The only way that would work out. All right? So that's how we put this down over here. And then I kind of plug the numbers in over there, and then lo and behold, I get e minus 1 in the end. All right? Tough question. If I were looking at questions on the exam and tell you what tough, 10 was tough, right? Almost impossible to get through that work, all right? Now, when I say that, some people are very good at this. Other people, a year later, they're not getting through that. And I'm also going to say 7 is tough, right? Can people do those things? Yeah. And you're going to be surprised. Did I say 7? I'm sorry, no, 8. 8 and 10 were tough, all right? They were really tough. Integrations, summations, generally are really difficult problems, all right? Now, I want to point out if you have questions or concerns, or you want to say, oh, I found a really easy way to do something, you know what? Reach out to me. This is my email address. And that's B as in boy, the @ symbol, NNON.US. That's my email address. Thank you for paying attention.